Hello and welcome back to my channel. Today in this video we are going to discuss the last few questions from exercise 1C, that is question number 7 to question number 15 from Concise Mathematics, Selina Concise Mathematics class 9th ICSE. It is from Selina. So without any delay, let's start with the question number 7. Here is the question number 7. If m is 1 over 3 minus 2 root 2 and n is 1 over 3 plus 2 root 2, find first one is m square, another is n square, and the third one is mn. So for the first two we require m square. In order to calculate this m square directly by taking 1 over m as 1 over 3 minus 2 root 2, it would be always easier if we rationalize the denominator of a rational number. So if we want to rationalize the denominator, we have to get this rationalizing factor of the denominator, that is of course 3 plus 2 root 2. So we multiply by numerator and denominator both the same thing. So the numerator become the identity a square minus b square, and denominator become a square minus b square. Numerator is as it is because 1 into anything is that number, and denominator become 3 square is 9, 2 root 2 square. 2 root 2 square is 4 times 2, because 2 square is 4 and root 2 square is 2. So 4 2s are 8, 9 minus 8 is 1. So lastly we got 3 plus 2 root 2. And similarly for n, 1 over 3 plus 2 root 2, in this case the rationalizing factor is 3 minus 2 root 2. We solve it, we got 9 minus 8 in the denominator, but in the numerator we got 3 minus 2 root 2, which will give us only 3 minus 2 root 2. Then it would be easier to calculate m square. 3 plus 2 root 2 whole square by a plus b whole square identity. 3 square is 9, 2 root 2 square is 8, and 2 times 3 into 2 root 2, 9 plus 8 is 17, and 2 3s are 6, 2s are 12, so 12 root 2. And similarly n square is 3 minus 2 root 2, because this is what we got as n by rationalizing the denominator. We take the square, again a minus b whole square. 3 square is 9, 2 root 2 square is 8, and minus 2 times 3 into 2 into root 2 is minus 12 root 2. That is going to be 17 minus 12 root 2. And the last one is mn. Mn, again if we are going to do it directly from the m and n value, given value, then also we will get 1. Otherwise, if we have it in the numerator, then we can simply multiply. It is a plus b, a minus b identity, a square minus b square, and that is going to be 9 minus 8 equals 1. Otherwise also, if we multiply 1 over 3 minus 2 root 2 multiplied by 1 over 3 plus 2 root 2, so we will get in the denominator a plus b, a minus b, that is a square minus b square, 9 minus 8. So it is also going to give us 1. So it is on us how we want to do this question. Now let's discuss the 8th question. If x is given as 2 root 3 plus 2 root 2, find 1 over x. So as they have asked 1 over x, so we have to write 1 over x value this, and then since the denominator is not rationalized, we should always focus on rationalizing the denominator, and for that we require the rationalizing factor of this, that is 3 root 2 minus 2 root 2, and we multiply it in numerator and denominator, and then we got numerator as 1 into whole thing is 2 root 3 minus 2 root 2, and denominator is a square minus b square. 2 square is 4 and root 3 square is 3, so 4 3s are 12. 2 square is 4 into root 2 square is 2, 4 2s are 8, and then we got 2, I have taken common, then root 3 minus root 2, and denominator is 4, so we can cancel this and we will get root 3 minus root 2 upon 2, that is 1 over x. The next part is to find x plus 1 upon x. So we have x already, we have taken the 1 upon x from the first part, so x is this, 1 upon x is this. So now we can simply take the 1 by 2 common, and how I have done, I have multiplied by 2 and divide by the 2, multiplied by 2, divide by 2, so that everywhere we will get 1 by 2. I have taken 1 by 2 common, and here we got 4 root 3, here we got 4 root 2, and then plus root 3 and minus root 2. And then it is going to be, there are like terms 4 and this, so it is 5 times root 3, and 4 minus 1, that is going to be 3 root 2, and then whole upon 2. Now once we have these values, this value, the third part is to find x plus 1 upon x whole square. So it means the square of this thing, and it is in the numerator, so we can directly calculate. 1 upon 2 square is 1 by 4, and this square is by a plus b whole square identity. 5 square, it is 5, root 3 square is 5 square is 25, and root 3 square is 3, so we got 75. Similarly 3 square is 9 into 2 18, and then 2 times 5 root 3 into 3 root 2. So 2 5s are 10 into 3 30. So altogether we got 75 plus 18 is 93, and here it is 30 and root 6, because root 3 into root 2 is root 6. So these are the values now. Now let's discuss the ninth question. Ninth question is, if x equals 1 minus root 2, find the value of x minus 1 upon x whole cube. So we have to calculate 1 upon x first, because if we are doing directly then it is going to be complicated. So first of all we will calculate 1 upon x, and 1 upon x means 1 upon 1 minus root 2. Again we have the irrational number in the denominator, so we have to rationalize it by taking the rationalizing factor of this. So that is 1 plus root 2, numerator and denominator. We got 1 plus root 2 upon 1 minus 2, because 1 square is 1 and root 2 square is 2. It is a plus a minus b, a plus b, that is a square minus b square. So we got minus 1 here, and numerator is 1 plus root 2. So we know that we can write 5 over minus 2 as minus 5 by 2. So it was this thing, there is a number upon minus 1, so we can simply write this number with negative sign ahead of it. So that's why I have written minus times 1 plus root 2. So they require the x minus 1 upon x whole cube. Now 1 over x is rationalized, the denominator is rationalized, so we can directly use it here. So x is 1 minus root 2 minus, and here it is also minus, so minus minus plus 1 plus root 2. And if we open it, we get 1 minus root 2 and plus 1 plus root 2. Root 2 minus root 2 plus root 2 got cancelled, 1 plus 1 2, and hence we got 2 cube, which is of course very easily obtained. It is 8. Now for the 10th question, we can see it is x given and we require x square plus 1 upon x square. So we are going to use this identity which we will discuss in the expansion chapter. So but for that case actually we require to use it here, and if we don't want to use it, we can do it directly also. I'll tell you by the other method where we are going to we're not going to use this identity, we are going to solve simply. So for anyway we are going to solve first of all 1 upon x. 1 upon x is 1 upon 5 minus 2 root 6, and then we will rationalize the denominator by taking the rationalizing factor, and it is a minus b, a plus b, as it is every time we have discussed. So 25 minus 24, because 2 square is 4, root 6 square is 6, so 4 6 are 24. So we got denominator as 1, so we got 5 plus 2 root 6 altogether. Now if we put x square plus 1 upon x square as x plus 1 upon x whole square minus 2, so we will get it here x value plus 1 upon x value, which we have here, and then we see that these two got cancelled, and we got 5 5 10 and whole square minus 2. So 10 square minus 2, 10 square is 100, minus 2 is 98. And if we don't know this identity, then how to do it? We have to calculate x square first of all by taking a minus b whole square identity. We get 49 minus 20 root 6. 1 upon x square of course we require, because we need to calculate the sum of it. So 1 upon x square is 1 upon x whole square, that is 5 plus root 2, because we have calculated it here. So 5 plus 2 root 6 whole square, this 49 plus 20 root 6. Now if we add these two, we will get 49 minus 20 root 6, 49 minus 20 root 6, because it is minus sorry, it is plus here, sorry, this is plus, so it is there, and then we cancel these two. 49 is 98, which we have already obtained from the previous one. So next one is show that this whole thing is 5. So whenever we have this type of question, first of all we need to search for the rationalizing factors. If there are rationalizing factor of each other, means 3 minus 2 root 2, we cannot see 3 plus 2 root 2 anywhere. So we have to rationalize it one by one. 2 root 2 minus root 7, again we cannot see anywhere, so we have to rationalize this also. Similarly for this, similarly for this, and similarly for the last one. So we have, we can see 1 over 3 minus 2 root 2 rationalization, and then we got 3 plus 2 root 2, 1 over 2 root 2 minus root 7 as 1 over 2 root 2 minus root 7 by multiplying and dividing by the rationalizing factor of it, and we got this. Similarly for 1 minus root 7 minus root 6, we get root 7 plus root 6, and 1 over root 6 minus root 5, we will get root 6 plus root 5 by rationalizing the denominator, and at the last we will get 1 over root 5 minus 2 as root 5 plus 2. And now we will substitute these values here. So we will get the first one, it was, let me zoom out. In the first one we got 2 plus root 2, so 2 plus 2 root 2, sorry. Next one is minus 2 times root 2 plus root 7. Third one is plus 1 over root 7 minus root 6, so root 7 plus root 6, and the last one is minus, next one is minus, so it is going to minus this, and the last one is plus, so plus this. So altogether what we got, we can see 2 root 2 got cancelled, or first of all I'll multiply by the, open the bracket by multiplying by minus, so this minus will make it plus, change the sign, sorry, not plus, minus 2 root 2 minus root 7 plus root 7 plus root 6 is there, and then we multiply root 6 plus root 5 by minus, we got minus root 6 minus root 5, and similarly the last one root 5 plus root 2, and then we can see it here, this is all we got, and then these two got cancelled, plus minus cancelled, plus minus cancelled, minus plus cancelled, and we got 3 from here and 2 from here, which will give us 3 plus 2, which is 5, and hence it is the right hand side and proved. And here is the question number 12. Rationalize the denominator of this 1 over root 3 minus root 2 plus 1. So whenever we have a number like this, where we have the two irrational numbers in the combination in the denominator, what we are going to do, we are going to rationalize it twice to make the denominator rational. So first thing, we can take root 3 minus root 2 together. It's not compulsory that we should always take the irrational number together. We can take the rational and like we could have taken root 2 and plus 1 together and find its irrational number rationalizing factor. But in this case I have taken root 3 minus root 2 together and plus 1, and rationalizing factor for this would be, of course it's like root a minus 1, so rationalizing factor of this would be root a plus 1. So here what we got, we have root 3 minus root 2, so it become root 3 minus root 2 plus 1, rationalizing factor would be root 3 minus root 2 minus 1. So you multiply and divide by the same number, and the denominator we get a plus b, a minus b, we got a square minus b square, that is of course 1, and the numerator become 1 into anything is going to be 1, so we got root 3 minus root 2 minus 1. So numerator as it is, root 3 minus root 2 minus 1, and denominator we if you expand it, we will get root 3 square, that is 3, plus root 2 square 2 minus 2 times root 3 into root 2, that is going to be 3 plus 2 minus 2 root 6, and minus 1 is already there. So let's add the like terms, root 3 plus 2 5, minus 1 4, and minus 2 root 6 as it is. Now we are going to rationalize the denominator, and we can see actually we can take 2 common, but it's not that necessary that we should always take this 2 common. And here the rationalizing factor would be 4 plus 2 root 6. So I multiplied and divided by the same thing, and the numerator is going to multiply the whole thing with the whole thing, and it means root 3 into this bracket minus root 2 into this bracket minus 1 into this whole bracket, and denominator become a plus b, a minus b, that is a square, 4 square is 16, and 2 root 6 square is 24, because 2 root 6 into 2 root 6 is 2 2s are 4, root 6 into root 6 is 6, that is 24. So 16 minus 24, and 60 minus 24 is minus 8, and numerator if we solve, root 3 into 4, 4 root 3, root 3 into 2 root 6 is 2 root 18, minus 2 root 2 4, minus 4 root 2 minus plus minus, root 2 into 2 root 6 is minus 2 root 6. Similarly minus 1 with this, so we got minus 4 2 root 6. And now we can see that there are some number which are like we can simplify more, like root 18. Root 18 can be written as 9 into 2, and 9 is 3 outside of the square root, so it is 3 root 2, and this become 3 2s are 6 root 2 because 2 is already there, so, and root 18 is 3 root 2. So we got 6 root 2, and here this is final, and root 12 can be written as root 4 into 3. So 4 will come out of the square root with as 2, so 2 2s are 4 root 3, minus 4 and minus 2 root 6. Now we can see some like terms like 4 root 3 and minus 4 root 3, they got cancelled. 6 root 2 minus 4 root 2 become 2 root 2, and minus 2 root 6 as it is, and minus 4 as it is. Now we can take 2 common from here because 2 is here, 2 is here, 2 is here, so we can take 2 common. It would be root 2 minus root 6 minus 2, and then we can cancel this, and we can multiply this minus inside. It actually we got from here as minus 1 by 4 times root 2 minus root 6 minus 2. Minus is outside, so we can simply multiply by this. So we will get 1 upon 4 minus into root 2 minus root 2 minus plus root 6 and plus 2. So I arrange this, and we can write this as 2 plus root 6 minus root 2, and that's the answer. Now come to the 13th question. If root 2 is 1 by 1.4 and root 3 is 1.7, find the value of each of the following correct to 1 decimal place. This is the actual reason why we do the rationalization, because in the rationalization, in the normal case, if we need to calculate 1 upon root 3 minus root 2, it would be 1 upon 1 minus 1.7 minus 1 by 4, 1.4. That is going to be a little bit complicated in order to calculate. So if we rationalize the denominator, that would be easier because it is always easy to multiply than divide. So again we have rationalized the denominator by this rationalizing factor root 3 plus root 2 multiplied, and denominator become a minus b, a plus b, that is a square, root 3 square is 3 minus 2, and numerator become root 3 plus root 2 because 1 into this number is the number itself, and this number upon 1 is root 3 plus root 2. Now 1.7 is root 3 value and root 2 value is 1.4. We can add and we can write it as 3.1, and it is always easier because we have only added it, and otherwise we could have if we want to find it directly, then in that case it would be 1 over 1.7 minus 1.4, that is 1 upon 0.3, and then it is going to be 7, it is minus 7 minus 4 3, 1 minus 1 0, 0.3, then it is going to be, you can take this here, then 10 by 3, then we have to solve this. So till 1 decimal place, that is the proper way, that's easy way to calculate. And 1 over 3 plus 2 root 2, similarly again we have to rationalize it, and we got denominator as 9 minus 8, that is 1, so it is easier, and 3 minus 2 root 2 in the numerator, that's why 3 minus 2 times 1.4, because 2 times root 2, 2 times root 2 is 1.4, that is 2 into 1.4 is 2.8, and 3 minus 2.8 is 0.2. Similarly here we have root 3. If we are putting root 3 as 1.7, it would be very difficult to divide, so we rationalize it. Just rationalizing factor is root 3 here in this case, because we have monomial, only one irrational number, and we got this as 2 root 3 minus 3 in the numerator, and denominator it is 3, so 3.4 minus 3 upon 3, that is 0.4 upon 3, and it can be solved as 0.133 and so on. So that's the till 1 decimal place it is going to be 0.1, and hence that is the answer. Now come to the 14th question and the last one. 14th question, we need to evaluate this. There is a sum, and as I told you, if in the denominator we have the rationalizing factor of each other, we are going to simply add them. If they are not rationalizing factor of each other, then we have to do it one by one, one at a time. So if we multiply, it is simply like 3 by 7 plus 2 by 5, where we multiply the denominator 7 into 5, and then we do the cross multiplication 3 into 5 plus 2 into 7. So that's what we have done it here. So 4 plus root 5 into 4 minus root 5, and then 4 minus root 5 would be multiplied by this 4 minus root 5, then it becomes square. Similarly, plus 4 plus root 5 whole square here. And then we use the a minus b whole square identity, 16 5 minus 8 root 5 and plus 16 5 and minus 8 root 5. Oh sorry, it is plus 8 root 5. It is not minus, it is plus 8 root 5 because it is plus 2ab. And then these two got cancelled, and we got 16 plus 5 21, 16 plus 5 21, and 21 plus 21 is 42 upon 11, that is 3 9 by 11 in the mixed fraction form. And we will leave our answer till here because they did not ask for the decimal values. The last question, 15th one, if 2 plus root 5 over 2 minus root 5 is x and 2 minus root 5 over 2 plus 5 is y, find the value of x square minus y square. So there are two ways. First one, we can use the identity x minus y into x plus y, then also we will get the same answer. Otherwise we can simply solve x first of all and then y, and then we calculate x square of it, and then we can find the last value. So I have done in this x equals rationalizing the denominator. We got 4 plus 5 plus 4 root 5 because it is a plus b whole square. Denominator is minus, so I took minus here because we know that minus let's 5 over minus 2 is simply minus 5 over 2. So I took this minus here, and hence x square becomes square of 9 plus 4 root 5. So this is going to be 81 plus 80 plus 72 root 5 by a plus b whole square identity. And then lastly we get 161 plus 72 root 5, and the same way y also we rationalize it and we get it as 99 minus 4 root 5, 81 plus 80 minus 72 root 5, that is 161 minus 72 root 5. And then we can calculate x square minus y square in this way just by replacing this value minus, so it changes the sign, and we can see these two got cancelled and we got 144 root 5. And in this way, if we want to use this identity, so we have x and y at this step only. So x plus y would be minus 9 plus 4 root 5 plus again minus 9, so minus will change the sign, minus 9 plus 4 root 5, and if you simplify we will get minus 9 minus 4 root 5 minus 9 plus 4 root 5. These two got cancelled and we got minus 18. And similarly we can calculate x minus y, that is minus 9 minus 4 root 5, and minus of this will be plus, so it becomes plus 9 minus 4 root 5. So we got these two got cancelled and we got it as minus 8 root 5. So if we find x square minus y square by this identity, we can simply multiply minus 18 into 8 root 5. In that way we don't have to do the square, and again 18 8s are 144, so minus 144 root 5, sorry, minus would be cancelled, so it is 144 root 5 would be the answer. So it's like the way we find easy, we can solve it. It is always the rationalizing the denominator. If we rationalize the denominator, our answer would be easily obtained. So that's it from exercise 1C, and we will discuss the next exercises in the next videos. Till then, thank you so much.